Hi, thanks for watching. Okay, we've talked a little bit about how proofs work and how the different parts of them fit together. So tonight we're going to learn a few more of the definitions. They're kind of the building blocks of the proofs that help us to prove theorems. They're kind of the glue that fits some of the different steps together. So we'll learn what a midpoint and a trisection point of a segment is. We'll look what an angle trisector and an angle bisector is. And will help you to see that these definitions are in conditional form, that if-then form, the hypothesis conclusion. And remember from the video on section 1.7 that definitions have that property that we can switch the order of the hypothesis and the conclusion without changing the truth value. That is, the converse and the original statement have the same truth value. So, good luck watching. Remember to pause if you have any questions and want to take any notes. And I hope you find this helpful. Thanks for watching. This section has several definitions that are all really closely related. It's important for us to point out the difference between a definition and its converse. Now remember, definitions are reversible, so the converse is going to be just as true. Nevertheless, there is a proper time to use one form over the other. Let's take the idea of segment bisector, for instance. Let's say you knew that you had a segment AB. Let's forget about this piece of information for now. But given this segment AB, you knew that AM was congruent to BM. You could say that M is dividing the segment into two congruent segments. Therefore, it bisects the segment. So again, what you were given, that the two segments were congruent, is restated here in the orange part. As you recall, that's the hypothesis. The conclusion, the then, is where we say that it bisects the segment. All right? Now, let's go the other way. Suppose that we were looking at the same picture, but we were given that M bisects AB. In that case, we would use the converse of this definition, where we'd say a point bisects a segment, because that's what's given, that M bisects AB, then it divides the segment into two congruent parts. So here, our given would be that M bisects AB, and our conclusion would be that the two segments were congruent. So it all depends on what information you're given. Whatever you're given, that becomes the if portion. That becomes the if portion of your definition. Okay, we should also at this time show you the midpoint definition and its converse. All right? So if a point divides a segment into two congruent parts, then it is a midpoint. So if you were told AM is congruent to BM, that would be the definition you'd want to use if you're trying to prove something's a midpoint. Conversely, if you were told that M was the midpoint of the segment, then it divides the segment into two congruent parts. Once again, that's the converse. Let's take an example. Suppose you were given M is the midpoint of AB. What conclusions could you draw by looking at this segment, or at this picture on the left? Think about it for a minute by pausing the video. Okay, the conclusions you could come to, given that M is the midpoint, would be that AM is congruent to MB. Or perhaps you could say GM bisects AB. Or M bisects AB. Let's take a look at this other drawing over here on the right. Here we're told that HJ is congruent to JI. Can you think of one or two conclusions that you can draw from just knowing that HJ is congruent to JI? Pause the video and think of some. Okay, some of the conclusions you could come to is that J is the midpoint of HI, KL is a bisector of HI, or M bisects HI. All right, let's move on to another definition. Very similar to bisection is trisection. So if you were given that AT was congruent to TP and those were congruent to PB, you could use this definition of trisect. If 2 points, like T and P, divide a segment into 3 congruent parts, then the points trisect the segment. These parenthetical statements here in the middle just show that segments, lines, or rays could be substituted in for the word points, both in the hypothesis and the conclusion. But once again, you see that the given information that we have 2 points dividing a segment into 3 congruent parts is the if. Always what we're given is the if. On the other hand, suppose we were given that T and P trisect AB. Well, then we would use the converse. The information about a trisector would come up in the if, or the hypothesis, and then the fact that it was divided into 3 congruent parts would be in the conclusion. Either way, the points, segments, rays, or lines are called trisectors. Okay, let's quickly turn our attention to angles. An angle bisector is a ray that divides a larger angle into 2 congruent parts. So imagine that you were working on a problem where you were given that 2 smaller angles were congruent that were part of a larger angle. You would use this definition. If a ray divides an angle into 2 congruent parts, then the ray bisects the angle. Again, what we were given, that ABD is congruent to CBD, shows up in the if, or the hypothesis, and our conclusion is that the ray bisects the angle. Conversely, if we were told that BD bisects angle ABC, that would show up in our hypothesis, and so the definition we'd use would be if a ray bisects an angle, it divides the angle into 2 congruent parts. If we saw that we had a large angle that had been divided into 3 congruent parts, we could recognize that the angle was trisected. And given that information, we would use this definition, that if 2 rays divide an angle into 3 congruent parts, then the rays trisect the angle. Once again, the congruent angles show up in the hypothesis of the definition. Now notice the converse of that will state that this given information. If 2 rays trisect an angle, then the rays divide the angle into 3 congruent parts. It all depends on what information is given to you in the problem or what you've already proved. Hi, I know that must have seemed really repetitive, but it's really important that we get the foundations for proofs, and knowing which form of a definition or of a theorem to use is really important. So it all depends on what you know or what you've been given. That is always the if part, or the premise, or the hypothesis. Alright, thanks again for watching. I hope this helps.